All right, now let's look at implicit differentiation. Okay, that's a really scary word, but let's not let that deter us away from figuring this out. Okay? So, if you see a question like this, step 1 is going to be take the derivative of everything. Take d dx of everything. Why? Because it says find dy dx. So we want our final answer to be dy dx equals something. Okay, so in order to do that, we need to start taking derivatives. The reason why this is implicit is because we're going to end up taking the derivative of y with respect to x, and that's what implicit differentiation is, okay? So that means we need to take the derivative of everything. You don't need to write it how I'm writing it, like d dx of this plus d dx of that. I'm just writing this so you can see clearly what I'm doing in each step, okay? Yeah. All right. Now, we can't just forget every single derivative rule we've ever learned, okay? We need to still use that, even though we're doing implicit differentiation. We still need to differentiate as we would, okay? So this one's nice and this one's nice because we can do power rule, and that's the derivative of a, whatever you call it, a constant, so that's going to be 0. So this first one is going to be 4x, and we know this last one is going to be 0. Now, the trouble, I guess you could say, would be these two, because this is x squared times y. Well, how do you take the derivative of something times something else? Well, that's the product rule. Same thing down here, product rule, because I have x times y cubed. All right, that doesn't go away. All right, let me move this down. Okay, let's do this product rule first, okay? So it does not matter which one we call which, but we need to call one of them f and one of them g. Why don't we do x squared and then y? Okay, so I need f prime and g prime. F prime is 2x. Now, g prime, let's be careful, okay? If this was equal to x, you would tell me, hopefully, that its derivative is equal to 1, okay? So we're still going to follow all of our derivative rules. So the derivative of y is going to be 1, but now this is the implicit step. Because I'm taking the derivative of y with respect to a different variable, I have to multiply by dy dx. dy dx is the same thing as y prime. Those are, they're the same notation. Or same thing, different notation. You can write whatever you want. I'm going to write dy dx. If you want to write y prime, write y prime. I don't care. Just as long as you understand that when you take the derivative of y, you have to multiply by dy dx, you're good. You're golden. Okay? So the derivative of x squared times y, well, we need to follow f prime g plus g prime f. That's product rule. So we'll have 2x times y, so this sees that, plus this times that, so x squared dy dx. All right, now let's do the other product rule. Let me do this one in blue. How's that? So we can keep everything organized. So this is product rule round 2. Same thing. Let's call one f, let's call one g. Let's do x, y cubed. Does it matter which one is which? No, unless you're doing quotient rule. But we're not doing quotient rule, so don't worry. All right, derivative of x is equal to 1. All right, y cubed. Again, we're going to take the derivative like normal. So that's 3y squared using power rule. What do I have to multiply by because I took the derivative of y? dy dx every time. That is the implicit step. All right, so we need to do f prime g plus g prime f again. So we'll have 1 times y cubed, which is y cubed, plus this times that. It doesn't matter which order you write this multiplication in. I'm going to do 3xy squared dy dx. Okay, and earlier we said this derivative was 4x, and we said this was 0. So now let's put all the pieces together. We're going to have 4x plus 2xy plus x squared dy dx minus, let's make sure this whole thing in blue gets subtracted, not just the first term, very common mistake. Okay, and then equals 0. All right, so we have all of the derivatives on the board. Like I said, our final answer needs to be this. Well, now I have dy dx on the paper, and I'm going to treat it like a variable that I'm going to isolate. So I have 2 of them, though, so I need to be a little bit careful. Let's first take care of this negative sign. So when I do that, we get negative, negative. So now, everything that does not have dy dx in it, I'm going to move over here, okay? So x squared dy dx stays, and 3xy squared dy dx stays. I'm going to move everything else over. I'm going to subtract 4x, subtract 2xy, and add y cubed. All right. Now, both of these have a dy dx, so what can I do? I can factor it out. I can do dy dx, parentheses, x squared minus 3x y squared equals all of this on this side. Why did we do that? Well, now dy dx is being multiplied by something. So how do I get something isolated if it's being multiplied? I do the inverse operation of division, which gives me dy dx is equal to negative 4x minus 2xy plus y cubed divided by x squared minus 3xy squared. And then we are done. Beautiful.